Alrighty, so to go over claim evidence and reasoning, I have some definitions for you and then two examples that we're going to go over. Hopefully, this helps clarify how you write claim evidence and reasonings. So, the definitions I mentioned. A claim is simply just an answer to a question. It's the shortest part of this entire thing because it normally ends up only being about a sentence. The evidence is patterns and graphs or actual data points or numbers that support the claim. So when you think of patterns in the graph, you can be using words that we learned, such as direct relationships, inverse relationships, or nonlinear, linear relationships. You can also use words like strong, weak, or no relationship at all. In addition, you can also choose particular data points that might help to support your claim. For example, we'll do the example when we actually get into the next one. So you can use actual data points as well to help support your claim. The last part is the reasoning. And this one is where you might have to do a little bit of research, but you're trying to come up with a scientific explanation that explains the evidence and also supports the claim. So let's take a look at the example from this morning. You had a scenario in which researchers are studying how conditions in Lake Michigan affect the organisms that live there. These researchers collected the following data about water temperatures at various depths within the lake. So look at our data table. We have water depth measured in meters. So we can go from a shallow depth of about 50 meters, or we can go all the way down to the bottom of the lake at about 200 meters. The temperature is measured in degrees Celsius. So for example, at 50 meters, the temperature was 18 degrees Celsius. At 200 meters, the temperature was 4 degrees Celsius. Now, I went ahead and took this information and I graphed it, and that's what's shown here on the right-hand side. Notice that the water depth is my independent variable because I can choose what depth I'm measuring at, right? So I'm going to put that on my x-axis. Then the temperature is what I'm observing or what I'm measuring. So that's going to be my dependent variable that goes on the y. Notice that the pattern in our data points here suggests that it's maybe an inverse relationship because if we were to draw a line through these points, it would kind of point downwards towards the right-hand side. So that would tell us that as the water depth is getting larger and larger, the temperature is getting smaller and smaller. So let's take some of those patterns, some of those ideas, and let's write a claim, evidence, and reasoning that helps us answer the question, how does the depth of water affect temperature? So my claim is simply the answer to that question. I believe that as the water depth increases, the temperature decreases. In more like common language, we would say as we get deeper and deeper into the lake, the temperature is going to get colder and colder and colder, right? So what evidence do I have that helped me draw that claim? Well, when I looked at the graph of temperature versus water depth, it shows a strong inverse relationship. And then I'm going to choose some data points that really help hit home that claim. I chose two data points that were on the extremes. I said, for example, at a shallow depth of 50 meters, the temperature was 18. At a much deeper depth of 200 meters, the temperature was only 4. Okay, so evidence, again, I'm using words like strong, weak, or no relationship. I'm using words like inverse relationship or direct relationship or no nonlinear relationships, right? If it kind of curves as well. So that's all part of my evidence. It's just data. Then my reasoning is, well, why do I see that pattern? What causes that to happen? So I did some research on Google and I said, why is the top of a lake warmer than the bottom of a lake? Or you could ask it in the opposite way. Why is the bottom of a lake so much colder than the top of the lake? One of the reasons that could explain that data would be this. Lakes have different temperatures at different depths due to the intensity of sunlight. Water that is closer to the surface is exposed to direct sunlight, which would make its temperature warmer. Water that is closer to the bottom of the lake does not get much sunlight. Water at that depth would have a much colder temperature. Okay, so again, claim is my answer. It's one sentence. Use words like increase or decrease in there. Evidence is explaining your patterns in your graphs and choosing some data points if you have them. And then the reasoning is your scientific explanation for why you are seeing that data and how does that support your claim. So we have one more example to go over, and this one is a little bit trickier. Take a look at this graph. It says a block of ice is placed over a constant source of heat for a period of time. The temperature is measured, and the state, meaning solid, liquid, or gas, is also noted. The graph at the right shows the results of this experiment. So let's take a look here. We have time on the x-axis, and just a reminder that we have constant heat source that entire time. On the y-axis, we have temperature. So notice that this seems to be a direct relationship because it's going up and to the right. That would tell us that as time is going on and temperature is increasing, that we're seeing changes from solids to liquids to gases. Okay. So let's see if we can write a claim, evidence, and reasoning about that. So the question is, how does temperature affect state of matter? And our claim is this: the higher the temperature, the less dense the particles become, and the substance will turn into a gas. So, does that answer our question? Yes. What evidence do I have that suggests that? Well, using my graph, I can pick out the following patterns. At colder temperatures, matter will be a solid, which means that the particles are densely packed together. As the temperature increases, solids turn into liquids and eventually a gas, and we know that gases are the least dense. Now, I will say, reading this over like one last time, we probably didn't need to include the information about the density in our evidence, right? Because that wasn't actually a part of our graph. Our graph didn't show us anything about density, just temperature and how matter can change from a solid to a liquid into a gas. But when we look at our reasoning, the density comes into play. So why is it that at colder temperatures, matter is going to be a solid, and at warmer temperatures, matter could be a gas? Well, we found out this reason why. Heat energy is converted into kinetic energy. And remember, kinetic energy is motion. As a substance heats up, the particles gain more kinetic energy and vibrate more. This causes them to spread out, resulting in solids turning into liquids and eventually gases. So I hope this kind of helps you. If you have any other questions, don't hesitate to email me. I can always, respond back to you via email. I'm just not going to be in class today. After you've gone through this video or you've gone through it with the sub, then you should be going and working on the assignment that's called Puppy Heartbeats. Again, it's a couple questions about variables, it's a graphing, and then you are writing your own claim, evidence, and reasoning.